you can see that the first formula that we have written down here is the p-product rule. Very good, product rule. Well, what I'm going to do is I'm going to take the product rule and I'm going to kind of, work with it to produce a way of doing, kind of undoing the product rule, okay? Because what we would like is we'd like something that says integral of f times g, right? Because we know f times g prime. We know what that is, right? That's what's sitting right there. Well, we want this expression. So what I'm going to do is I'm going to start by replacing big F for little f. What is the relationship between big F, little f, and f prime? Very good. Big F is the antiderivative of f. So if I put f, big F, where little f is, then what would I have to put where f prime is? Yeah. If this goes into here, then this goes into here. Everybody see that? So let's do it. Instead of big F, what do I write? Or instead of little f, what do I write? Big F times g prime equals, instead of f prime, what am I going to put? Just f times g plus g prime times big F. Very good. Well, again, so if I'm going to put big F in the place of little f, then little f has to go in the place of f prime. Okay? So we're just going one step removed in terms of its derivative. All right? Now, I'm going to do a little trick here. It looks like I've got my f times g, correct? Well, now I'm just going to throw an integral sign there. So if I take the antiderivative of each side, you can see that you can take the antiderivative of each of those parts. Okay, you have plus, so you just do each part. And this requires you to see when you put an integral sign here and you have a derivative sign there, what happens? They go away. And so you have big F times g is equal to integral of fg plus integral of g prime big F. Now, is it the case that we have this symbol somewhere in our work? Yeah, we got integral of f times g. That's what I want to solve for. How would I solve for that? Big F times little g minus the integral of g prime big F is equal to the integral fg. Or if I write it, instead of backwards, if I write it forwards, I guess we can think of forwards and backwards, you would integral of fg is equal to big F little g minus integral of g prime big F. And that's your formula for integration by parts. This tells us how to undo the product rule. So the antiderivative of two functions that are multiplied together. So look at your first example, the integral of x times sine of x. So when you do the product rule, you try to identify what is f and what is g, right? Well, here we need to identify something a little bit different. We need to identify what is f and what is g, but think about it ahead of time. What do you end up doing to f? Yeah, you're taking the antiderivative of it. So choose f to be something you know the antiderivative of. Does that make sense? Okay. So now let's think about g. What happens to g? You take the derivative of it. So choose g to be something you know the derivative of. Now, it doesn't always work like this, but you'd also like it if it terminates. And I'll explain what that means in a second here, okay? I hope that there's some things that you've learned through this course. And trust me, I know that you don't remember everything. We've kind of gone through that point, right? You take the AP practice test and you understand that some of the content we've covered, but you don't really remember, right? We've gone down that road, and we're okay with that. I'm okay with that as a teacher. I'm okay with the fact that we forget some things. But I'm confident that you guys know how to take the derivative of functions. Taking derivative, that's something you're like, yeah, I can do that, right? If you guys all agree that you've come through calculus and you can say, I can take a derivative. And generally speaking, you're pretty good at finding limits as well. Okay, so good job. Every once in a while, you do L'Hopital's rule, and it's a good time. Would you also agree that after going through calculus, would you agree with the statement? It is easier to find derivatives than it is to find antiderivatives. Can we all agree with that antiderivatives is kind of a, like, we're still not sure some of the things out there that we might encounter for antiderivatives, like we're investigating today. So follow me as we do this piece right here. True or false? We know the derivative of sine. True or false? We know the antiderivative of sine. Okay. True or false? We know the derivative of x. True or false? We know the antiderivative of x. So which one would we choose to be f, and which one would we choose to be g? The fact is that I have the ability to take the antiderivative or the derivative of either. Well, watch. If we take the derivative of sine is positive cosine. And then derivative of cosine is negative sine. Derivative of negative sine is negative cosine. Derivative of negative cosine is, and we're right back to where we started, right? But watch what happens if we choose x. Derivative of x is, derivative of 1 is, and it's gone, right? So when you're trying to choose, it's nice if you could choose g to be the one that when you take the derivative of it, it eventually terminates, kind of goes away. So like a polynomial, for example, like x or x squared or something of that nature. And we'll choose f to be sine of x. So as I take this derivative, hi buddy, how you doing? So glad you came back to visit. Just couldn't get enough of integration by parts, huh? That was sarcasm. So I'm going to write this out. The integral of f times g is equal to big F little g minus the integral of g prime big F. Does everybody agree with that that formula? I mean, that's what we wrote down. So I'm going to write this. The integral of x times sine of x is then equal to, what is big F? Somebody tell me. Negative cosine of x. You good? Times, what is g? X minus the integral of, what's g prime? 1 times big F, negative cosine of x. We have a dx because we have an integral sign. Oh, I forgot to write my dx there. Bad teacher. It does, yeah, it doesn't say take the derivative there. So we have negative x cosine of x, and then the two negatives will cancel out, won't they? So I just have plus integral cosine of x dx. So in order to finish this problem, all I have to do is now identify the antiderivative of cosine of x. So I have negative x cosine of x. What is the antiderivative of cosine? Sine plus a constant. So that's the antiderivative of x sine of x. How can we check that? Take the derivative. What? So watch, I'll take this derivative. If I'm going to take the derivative, what rule do I have to use there? The periodic rule. Derivative of negative x is negative 1 times cosine of x plus negative x times, what's the derivative of cosine? Negative sine of x plus, what's the derivative of sine of x? Cosine of x, what's the derivative constant? 0. What happens to the cosines? And what's negative x times negative sine? And so you get what you started with. Oh yeah, it's totally cool. I mean, if you... This is the answer. This is your antiderivative. This is the confirmation of the answer. Yeah, you can check every answer. Trust me, guys. There's times where I do like an antiderivative I've never done before, and it's like I get this inner like temptation side. Like, oh, I should check it by taking the derivative, and you know, it's okay to give into that temptation. It's a good thing. Okay. It's like there's like math. No. Checking your answer by taking a derivative. Yes. Okay. Everything in moderation is okay. That's a lie. Okay. No. Here's an example. Here's an. Okay. Here we go. Let's flip over the back. Look at this. Antiderivative of natural log of x. Now, what's interesting here is the question is we've got f and we've got g. Now, great response, 1 over x, except what's wrong about that? What is 100% incorrect about that statement? The derivative of natural log is 1 over x, not the antiderivative, right? No. We don't know what the antiderivative is because we don't know how to do it. Fortunately, we have integration by parts. So we need to choose f and we need to choose g. G has to be something that you can take the derivative of. F is something that you take the antiderivative of. So do you know the derivative of natural log? So natural log would be g. So this is the big question then. F is 1. Because what's the antiderivative of 1? X. Not really. So we're going to do 1 times the natural log of x, where 1 is f and natural log is g. So I have this rule, the integral of fg is equal to big F times little g minus integral of g prime big F. We're going to go to work with that. It's a beautiful thing. What is the antiderivative of 1? X times what is g? Natural log of x. So far, so good. We're very easy. Minus the integral of what's g prime? 1 over x times what's big F? X, right? Right, so we get x natural log of x minus the integral of 1 dx. Callan, what's the antiderivative of 1? It is x. So we got x natural log of x minus x plus a constant. That's the antiderivative of natural log. Not 1 over x, that's the derivative. Pretty good, huh? You try the next one on your own. And I believe that you can do it. Okay, everybody okay with that? Yeah, and the cool thing is if you take the derivative, you're going to end up with, obviously, that x to the 4th natural log of x. So that takes care of a couple examples for us. We're just going to do 2 more here. And we're just going to get slightly more challenging. Okay? So, example 4. You've been very intelligent so far. We're going to choose f, and we're going to choose g. What do you think f should be, and what do you think g should be? F should be e to the x. Very good. And g should be 3x squared. Because, you know, if you choose e to the x to be g, the derivative of e to the x is e to the x. It just cycles through. But if you choose to be f, the antiderivative is g e to the x. It just continues to cycle through. So it's nice if this is g because, you know, 3x squared, then 6x, then 6, then 0. So let's set it up. I'm going to write the rule again just so we can all see it. Fg is equal to big F little g minus integral g prime big F or big F g prime. You know, multiplication is commutative. Whatever's easier for you. Nope. I see you guys memorize all sorts of stuff for your other classes. Should be no problem if you memorize about 3 or 4 formulas. Okay, here we go. Integral of 3x squared e to the x dx is equal to, we'll start with big F. What's big F? E to the x times g. What's g? Isn't that interesting? It starts out exactly like it looks. minus integral of, what is g prime? 6x e to the x dx. Jill, do it again. So Jill recognized that there's no way, I mean, she recognized that I very well could have just, instead of giving you 3x squared e to the x, I could have given you 6x e to the x, we would have had to do integration by parts. I mean, this is an antiderivative that involves integration by parts as well. So we'll just do it again. So we're going to call this f, and we're going to call this g. We're just going to go to work. 3x squared e to the x. How did I know Jill had the answer? What's little g? 6x e to the x. We still got the 3x squared e to the x. It's going to be minus 6x e to the x. Plus whatever the antiderivative is of 6e to the x. What's the antiderivative of e to the x? What's the antiderivative of 2e to the x? 2e to the x. What's the antiderivative of 6e to the x? Yeah, the constant just comes along for the ride. So we have 6e to the x. No. I distributed the negative through the subtraction, or the subtraction sign through the parentheses. Don't forget the plus c. I will take points off. Okay. Carter raises an excellent question. Watch. Suppose I changed it. Suppose I chose this to be f. Isn't it nice that if this is g, it went from 3x squared to 6x down to 6? I mean, we eventually knew how to take the derivative, or the antiderivative of 6e to the x, didn't we? But suppose we would have chosen this to be f. Then we would have started out with a x cubed, and then we would have gone to x to the 4th over 4, and then we would have gone to x to the 5th over 20, then we would have gone to x to the 6th over 120, and we would have just kept on going, right? Because we would have been increasing powers. In this situation, we were able to drop powers from our 3x squared. Okay. Now, I'm going to show you one thing I can do to make this problem significantly more difficult. Because right now you guys are all like, oh, no big deal. Well, what if I did this? Integral of 3x e to the x dx. But instead of 3x squared, we'll go 3x to the 12th. I would have to do 12 times. I would have to do integration by parts, right? I will show you a shortcut for that on Monday. Yeah, I wouldn't do that to you, but you know, I definitely want you to be able to do it twice without having to use a shortcut, because it's not that big of a deal. But you know, I wouldn't have you do it. Oh yeah, it would be 12 times right here. You look like something. All right, here we go. We do. Let's try this one. Okay. What's different about this example? We'll end with this for today. Yeah, it just cycles through. E to the x continues to cycle, and cosine of x continues to cycle. So it does not exist. I love it how you always just look for the quick answer there, and that's entirely incorrect, 100% incorrect. Okay. We can easily find the solution. The question is choosing f and choosing g. Now, do you know the antiderivative of e to the x? Do you know the derivative of e to the x? Do you know the antiderivative of cosine? Do you know the derivative of cosine? So really, you could choose either or. What I'm going to do is I'm going to say, which one would I rather take an antiderivative of, and which one would I rather take a derivative of? I mean, it doesn't matter if e to the x is the derivative or antiderivative. Either way, it comes up to e to the x, correct? But cosine of x, would you rather be taking derivatives or antiderivatives for cosine and sine? I prefer taking derivatives personally. That's where I live there. So we're going to call this g, and we'll call this f. So therefore, I have the integral of e to the x cosine of x dx is equal to, I'm not going to write down the formula because you remember it so well. Big F would be e to the x times little g minus integral Yep, so it would be a negative sign, so it would switch to plus sine of x times e to the x dx. Or maybe it would just look better if I wrote it as e to the x times sine of x dx. Sweet. Well, do it again. So this would be f, and this would be g, because the derivative of cosine was negative sine, so the negatives cancel. So now we have e to the x cosine of x plus, if I have a plus sign, do I need parentheses? No, I don't need parentheses if I have a plus sign. No big deal. Plus, let's do integration by parts. Big F, little g, minus the integral of big F, little g. I'm sorry, g prime, excuse me. Isn't that what we started with? So we would just continue to cycle through forever, wouldn't we? Somebody just see it. No, 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 no. Come on, folks. Come on. Try to give you a hint. There you go. We're going to add it over to the other side. So now how many integrals do we have of e to the x cosine of x dx? We have two of the integrals e to the x cosine of x dx. And what remains on the right-hand side, we just have a basic equation here, e to the x cosine of x plus e to the x sine of x. And well, we're really close to the final answer. What we wanted at the beginning was the integral of e to the x cosine of x dx. We have that, but it's currently being multiplied by 2. So if we just divide it by 2, we end up with the integral of e to the x cosine of x dx is equal to e to the x cosine of x plus e to the x sine of x over 2 plus a constant, piece of cake upside down. Isn't that awesome? Thank you, Gina, for your approval of our mathematics. works